Okay, parallel and perpendicular lines. Two lines on a graph that never cross are called parallel lines. These lines have slopes that are equal. Two lines on a graph that cross at a 90-degree angle are called perpendicular lines. These lines have slopes that are opposite reciprocals. Okay. In the graph to the right, sketch two parallel lines in the fourth quadrant. In the second quadrant, sketch two perpendicular lines. Okay, so in the fourth quadrant, I'm just going to sketch two parallel lines. So that's just going to be two lines that have the same slope and aren't the same line. So this one I'm basically going something like that. I'm sketching them. And for perpendicular lines, in the second quadrant, I'm going to do, we could do, so let's do this and this. Okay. Alright, so these are parallel down here. They're never going to touch each other. They have the same slope. And the perpendicular lines, they're going to form a 90-degree angle here. So it's two lines that cross and form a 90-degree angle. Okay. Alright, recall that the slope-intercept form of a line, y equals mx plus b, is used to graph and write equations of lines. In this equation, when the y is by itself, the letter m is the slope and is always the coefficient of x. That means it's the number that comes in front of x. Okay, parallel. The slopes of parallel lines are always the same. If I was to do a quick example of that, so if I wrote y equals 3x minus 1, a line parallel to that would be y equals 3x plus 3. We can see that the slope is the same, so those would be parallel. Perpendicular. The slopes of perpendicular lines are always opposite reciprocals, which means you take the slope, the fraction of the slope, and you change the sign. If it was positive, it becomes negative. If it's negative, it becomes positive. And then you flip the fraction over. So here are some examples, or here's an example of what I'm talking about. If I took that same equation, y equals 3x minus 1, and I wanted to write a line that was perpendicular to that, I would take the slope, which is 3, and I'd make it a fraction. So it'd be 3 over 1. Then I need to flip the fraction over, so y equals 1/3, and then it was positive, so now I'm going to make it negative. So it's negative 1/3 x minus 1. Okay. So we've taken that slope, we've flipped it over, so it was 3 over 1, now it's 1 over 3, and we changed the sign. It was positive 3, now it's negative 1/3. Alright, in the following examples, indicate if the slopes are parallel, perpendicular, or neither. So first thing we want to look at is to see if they're parallel. That's the easiest thing to identify. So I'm going to look at example 1, and it says y equals 3x plus 1 and y equals negative 3x plus 1. So the slope in the top one is positive 3, and in the bottom one it's negative 3. In order to be parallel, they have to be exactly the same, and they're not. So they're not parallel. If they were perpendicular, we would have to see opposite. So they are opposites, one's positive, one's negative, but then the fraction has to be flipped. So if I make the top one a fraction of 3 over 1, in order for it to have to be perpendicular, it would have to be the opposite reciprocal. So we would flip it and change it from a positive to a negative. So we should see that as the slope, and we do not. So this one is neither. Okay, and the second one, example 2, we're going to look at the slope. The slopes are exactly the same, so we know that they are going to be parallel. So slopes are the same, then they're going to be parallel. Okay, example 3. We're going to look at the slopes to determine if it's parallel, perpendicular, or neither. So this one has a slope of positive 5. This one has a slope of negative 1/5. So they're not the same, so they're not parallel. Now we just have to decide if it's perpendicular or if it's neither. So in order to be perpendicular, we're going to take the first slope, which is 5. We're going to write it as a fraction. It's 5/1. Then, in order to make it perpendicular, I would have to flip the fraction. So that's the reciprocal, and then it would be the opposite of the sign would be the opposite. So it was a positive 5/1. Now it's negative 1/5, and that does match. So this would be perpendicular. Okay, given the following equations, write a new equation that is parallel to the given line and passes through the given point. Write your final answer in slope-intercept form. Okay, so example 1, y equals 2x plus 5, and it has to go through that point, negative 4, 5. Okay. So we know that we're looking for parallel lines, so the slope has to be the same. So our slope is here, 2. So we're going to write m equals 2. And then we're going to take that point, this point, and we're going to take that and the slope and put it into y equals mx plus b. Okay, so now I know 3 of the pieces. I know the m, I know an x and a y. I get those from here. So we'll label these x, y, and then we'll substitute the values in. So y is 5. That equals the m times x, so 2 times negative 4, and then plus b. We don't know that yet. 2 times negative 4 is negative 8, plus b, and that equals 5. We'll add 8 to both sides. So b equals 13. So now I need to write a new equation. I have the slope of 2 and the y-intercept of 13. So I will substitute those two values into y equals mx plus b to write my new equation that would be parallel to this first one here. Okay, so y equals 2x plus 13. So now when I compare it, the slopes are the same. They both have a slope of 2, and their y-intercepts are different, so they cross the y-axis at different points. Okay, example 2, 8x plus 4y equals 5, and it needs to go through the point 2, negative 8. So first thing that I want to do is I want to take my standard form equation and I want to write it into slope-intercept form. So to do that, I will move the x's by adding the opposite. So now I have 4y equals negative 8x plus 5, and then I will divide everything by 4, and that gives me y equals negative 2x plus 5/4. Okay, I want to write an equation for a line that is parallel to that, so I will need to use -2 for the slope, and I will need to use this point to find my y-intercept. So I will take the equation y equals mx plus b, and I'm going to substitute in the three pieces that I know. So y is -8 equals my slope, which is -2, so -2 times x, which is 2, plus b. -8 equals -4 plus b. Add 4 to both sides, and I get -4 equals b. Now I take that b and this slope, and I use that to write a new equation for the line that's parallel to this first one, or to this one. They're the same thing. So y equals -2x minus 4. Okay, we're going to do the same thing on this. Y equals -1/4 x minus 3 goes through this point, 8, -2. We're also going to write an equation that's parallel to this one. So we know that we're going to have the same slope, but a different y-intercept. So we need to figure that out given this point and that slope. So we will use y equals mx plus b and substitute in the three values that I know. I know m, x, and y. So y is -2. That equals the slope, -1/4, times x, so times 8, plus b. -1/4 of b is -2. Oh, -2 plus b. Then we will add 2 to both sides, and this gives me 0 equals b. Okay, so to write my equation that is parallel to this one, we're going to use the same slope, and we're going to use our newfound intercept. So we're going to take y equals -1/4 x plus nothing. So we could put plus 0, or we can leave it off. And we should leave it off, because anything plus 0 is itself. Okay, so -1/4. Okay, example 2. Y equals 6/5 x plus 2, and it needs to go through point -10, 3. So we're going to use the same slope again, so 6/5, and then we're going to use the slope-intercept form y equals mx plus b. Substitute those three values in and solve for b. So y is 3, m is 6/5 times x, which was -10, plus b. Alright, so 3 equals 6/5 of -10. That's going to be -12 plus b. Add 12 to both sides, and we get b is equal to 15. So we'll use y equals mx plus b again to write our new equation. So y equals 6/5 x, because we want the same slope, so 6/5 x plus 15. So these equations have the same slope, so that tells me that they're going to be parallel, and they have different y-intercepts. Okay, example 3. We need to do the same thing, but first we need to put this standard form equation into slope-intercept form. So it needs to be y equals mx plus b. Okay, for this there's two steps. We're going to move the x's and divide by the coefficient of y. So it's move the x, divide by the number in front of y. So minus 4x, both sides, leaves 2y equals negative 4x plus 8. Divide everything by 2. Y equals negative 2x plus 4. Okay, the slope is negative 2, so our new equation, so for y equals mx plus b, we're going to use this slope and this point. Okay. So the y is 5, and that equals the slope negative 2 times x times 10 plus b. Negative 2 times 10 is negative 20, and that should equal 5. And we will add 20 to both sides. We find that b is equal to 25. So now we're going to use the slope, the same slope for it to be parallel, and the new y-intercept to write our new equation of the line. So y equals negative 2x plus 25. So this equation has the same slope as this equation here. So they are parallel. Okay, we have two special cases, 4a and 4b. 4a says y equals negative 6. So this is going to be a horizontal line that passes through the y-axis at negative 6. And on 4b, this is a special case. It's a vertical line that passes through the x-axis at 4. Okay, so for 4a, we want to write an equation. So it's going to be y equals something that passes, or that is parallel to this. So it also has to go through that ordered pair. So we're going to take y equals, and then all I have to do is look at the x and y values over here. And for y, it's going to equal 4. So for this horizontal line, it's going to pass through the point, or through the y at 4. So if I was to graph this quickly, okay, if I took y equals negative 6, that's going to be around here somewhere. So that's y equals negative 6. And the one that we're saying is parallel is when y is equal to 4. That's going to be up here somewhere. Or we'll put it here. So y equals 4. These two lines are parallel. Okay, for 4b, we can do the same thing. We can draw a graph. Oops. We can draw a graph. And we know that x is going to be 4, so we can draw our vertical line here. Okay, and we're going to write that this is x equals 4 for that line. Then we know that it's going to pass through negative 3, 5, so back 3, approximately, and up 5. So we're looking for a point right around here. And then we're going to draw a vertical line through that, because it needs to be vertical as well, since it's going to be parallel. And if I was to write an equation for this line, I would see that the x value is negative 3. So I would just write x equals negative 3. And these lines are going to be parallel. Okay, the directions for the next section. Given the following equations, write a new equation that is perpendicular to the given line and passes through the given point. Write your final answer in slope-intercept form. Okay. So the key word was perpendicular. So perpendicular, I need to automatically think opposite reciprocal, or flip and change is another way that can be said. So we're going to take the slope, which is 3, and we are going to flip it and change it to show that it's, or to make a perpendicular line. So the slope was, or is, 3 over 1, and we want to flip it. So we're going to make it 1/3, and then we're going to change it to a negative. Okay. So our new slope for a perpendicular line is going to be negative 1/3. So we're going to take that slope and this point, and we are going to find the y-intercept now. So y equals mx plus b. We know the x, the y, and the m. So y is negative 8. That equals the slope, negative 1/3, times 6, so times the x, plus b. Oops. Plus b. So negative 8 equals negative 1/3 of 6, so that's going to be negative 2 plus b. Add 2 to both sides, so negative 6 equals b. So I have a new y-intercept and a new slope. The new slope is the opposite reciprocal. Okay, so I will write that in y equals mx plus b. So y equals negative 1/3 x minus 6. So if we look at it, the slope's opposite reciprocal, so this would have been 3 over 1. So we flipped it to 1/3 and we changed it from a positive to a negative. And then we have a new y-intercept that we found, and it would go through that point. Okay, we're looking for a perpendicular line to this one as well. So we are going to take the slope, negative 2/5. We're going to flip it. So we're going to make it 5 over 2. And then we're going to change it from this negative to a positive. So our new slope is 5/2. We're going to take this slope and this point, and we're going to find a new y-intercept. So we will substitute those values into y equals mx plus b. So y is negative 3. That equals the slope times x plus b. So negative 3 equals 15 plus b. Subtract 15 from both sides, or add a negative 15 to both sides. We find that b is negative 18. So we're going to take this slope and this y-intercept to write a new equation that is perpendicular to y equals negative 2/5 x minus 5. So y equals positive 5/2 x minus 18. So these two lines are perpendicular. It's the opposite reciprocal, and they have a different y-intercept, and it also would go through this point. Okay, perpendicular again. So the slope here is negative 1, so I can write that as a fraction. So it's negative 1 over 1. If I flip it over, it's still going to be 1 over 1, and now we need to change it to a positive. So it's positive 1 over 1, which is the same thing as 1. So I'm going to take that slope of 1 and this point, and I'm going to write a new line with that, or write a new equation of a line with that. So y equals mx plus b, and we are going to substitute the x and y values in. So 7 equals 1 times 1 plus b. And we get b equals 6. So we have a new y-intercept, and we have the new slope, which is positive 1. So when I write this equation, we get y equals 1x, so we're just going to put x plus 6. So I took the 1 from the new slope, put it here, so 1x, so 1 times x, plus the b, which was 6. In this example, we need to write this equation. It's in standard form. We need to put it into slope-intercept form, so it needs to be y equals. So we will add 2x to both sides and get 5y equals 2x plus 1. Divide everything by 5, and we get y equals 2/5 x plus 1/5. We're only worried right now about the slope because we want to find one that is perpendicular, so we have to take that slope, flip it over. So we flipped it here, we flipped the fraction, and then we're going to find, and then we're going to make it the opposite sign. So it was a positive, now it's going to become a negative. And we're going to take this point and this slope and find a new y-intercept for the new line. Y equals mx plus b. Y is negative 11. The m is negative 5/2 times x, which is 10, plus b. Negative 11 equals negative 25 plus b. Add 25 to both sides. And b equals 14. So we're going to take that intercept and that slope and write our new line, or write our new equation for the line. So y equals negative 5/2 x plus 14. We can see that the slopes are opposite reciprocals, or they've been flipped and changed, and then we have different y-intercepts. This was 1/5, and now it goes through 14. Okay, we're going to change this to y equals, so we will add negative 10x to both sides. Leaves us with negative 5y equals negative 10x plus 6. Divide by negative 5. Get y equals 2x minus 6/5. We are finding a perpendicular line, or the equation for a perpendicular line, so we need to take this slope of 2, make it a fraction, so 2 over 1, flip it, and then do the opposite. So it was a positive, now it's a negative. We're going to take this point and that slope, and we are going to find the new y-intercept. So we will substitute those values in to y equals mx plus b to find b. So y is negative 6, and that equals the slope times x, and then plus b. So negative 6 equals 3 plus b. Add negative 3 to both sides, and b is equal to negative 9. So we're going to take that y-intercept, that slope, and write a new equation. So y equals negative 1/2 x minus 9. Okay, for A, and B, these are special cases. These are going to be our horizontal and vertical lines. So if it's y equals 3, I can just draw a little graph real quick. Oops. Alright, so we're going to draw a little graph, and y is going to equal 3. So we can say it's going to cross something like that. So this is the line y equals 3. Now if it's going to be perpendicular to this, that means it's going to have to be a vertical line going through it. So if I have a horizontal, to be perpendicular, it would have to be a vertical line. And if it has to go through this point, it means I need to go back 16 on my x-axis and up 2. So the point would be, I don't know, somewhere over here, off the, over here. So I'm going to draw a vertical line to represent that. Okay. And the question is, where does it cross the x-axis? Well, it's crossing at -16. And since it's one of those special cases, we're going to write the equation for this line as x equals -16. Okay. On the one next to it, we could draw a graph for that one as well. And it's saying x is -1, so that means it's going to cross the x-axis at -1, so x equals -1. And if I want a line that is perpendicular to that, that means it needs to go horizontally. And it also needs to go through this point 1, 2. So if I go over 1 and up 2, that's about here. So I need to draw a horizontal line through that point. And then I would write an equation for that. So it crosses the y-axis at 2. So this would be y equals 2.